Hello everyone, welcome to the second video of calculus. Today we're going to be talking about natural domain and functions and range. So hopefully you have your sheet in front of you or sheet to take some notes on. At the end of the lesson today there will be some worksheet for you to do on your own that we will be grading when you come to class tomorrow. So we're going to start off today talking about a little bit about functions. Now, when you're in Algebra 2 and Algebra 1 and PropStat and all those good classes, you learned a little bit about functions. And you probably learned terms like input values and output values. And in calculus, we refer to input values as the domain. We know them as the x values, the values that go into a function. The output values, which are the y values, the values that come out of the function, we refer to those as range. The domain is the set that contains all the input values for a function. So it's a set of numbers or a listing of the numbers or a definition of the numbers that go into the function. Okay, so in this function, y equals 2x minus 5, the question is there any number that we could not put in for x? So if you think about that for a minute, the answer is no. We can put anything we want into that function. It's just a straight line with a slope of 2 and a y-intercept of negative 5. There is no value of x that causes a problem for that function. So therefore, if there's no problem with it, if we can substitute any real number for x, we say then that the domain of the function is the set of all real numbers. And the way you write this using the symbols of algebra is you write it as x is in the set of all real numbers. This area up here that you can see where my pen is. This area, this is what you're used to in Algebra 1 and Algebra 2. The x is at all real numbers. In calculus, we're going to start using a new notation called set notation, which we write this way. The set of all real numbers is all the numbers from negative infinity up to infinity. Now, when we put 11 in for x into that function, y will be 17. And remember, we're doing 2x minus 5. So 17 belongs to the range of the function. The function's y equals 2x minus 5. We plug in 11, we get out 17. The input is 11, the output is 17, so that's the range. Thinking about this, is there any number that we would not be able to get for y by putting in some number for x? Picture the graph. One of the things I want you to start doing in this class is you want to start when you get a function in front of you, y equals 2x minus 5 or y equals x squared or y equals the square root of x, any function that you see, you have to start visualizing the graph. What does the graph of the function look like? In this case, we're talking about y equals 2x minus 5. From Algebra 1, you know this is just a straight line. So if you imagine on a graph, if you have a straight line with a slope of 2, then what's going to happen is that's going to cover everything. So for example, I wanted to draw a picture. If you have a straight line that looks like this, it's just a straight line. It keeps going up and up and up forever and down and down and down forever. Here's your y and here's your x. So this straight line, it covers every single possible x value, but it also covers every single possible y value. So therefore, not only is the domain the set of all real numbers, but the range is also the set of all real numbers. And so you would say that using this notation. Instead of x, it's y, so y is in the set of all real numbers. And in set notation, once again, we would say it goes from negative infinity up to infinity. It encompasses all possible numbers in that range. Now, the next little thing to think about is it's not always true that the domain and the range can be any real number. And this is where things get interesting. Sometimes mathematicians would want to define a function, or we want to study a function over a very set interval or over a limited domain. And so in this case then, you have to narrow your focus. Instead of looking at the graph as a whole, you're looking at just a portion of the graph. And what I would do in that case then is I would tell you what interval we're interested in. Now, we might be considering a function like this one, y equals x squared minus 4, and we want to focus on x being between negative 3 and positive 3. So we're not interested in the entire graph of this function. We're only interested in a very small part of it between negative 3 and 3. And the way we would say this is we would say we're interested in this function down here at the bottom. Nope, let me go back a minute. So we're interested in this function down at the bottom, y equals x squared minus 4, over this domain, negative 3 up to 3, right, between negative 3 and 3. And I just see a typo on my slide here. If we're interested in between negative 3 and 3, this should be a parentheses, right, because there's no equal sign here. So we're going up to negative 3, but we're not including negative 3. We're going all the way from there up to positive 3. Now, earlier I said whenever you get a function, I want you to start thinking and visualizing what is this function going to look like on a graph. Hopefully you know from Algebra 2 that this is a squared, x squared. So we know what this graph looks like. This is a parabola, and it's down at negative 4. And if you don't remember this, it's okay, because the next video you're going to see, we're going to talk about transformations, and we're going to go over some of the basic functions. But an x squared function is a parabola, and in this case we're only interested in between negative 3 and positive 3. So we're going to start our graph here and end it here, and we're not going to look at any other portion of the graph. Now, sometimes the function itself will limit the domain or the range, and this is something that we're going to spend more time on. So in this case we have y equals 1 over x minus 3. In this function, can x be any real number? Is there any value of x that won't work? And hopefully when you're looking at it, if you focus on the bottom, if we plug in 3, we have a problem. Because if you plug in 3 into this function, you'd have to divide by 0. And we all know dividing by 0 is not allowed. So therefore, for this function, x can't be 3. We can never divide by 0. Otherwise, we have big problems, so we can't do that. So we have to eliminate 3 from the domain. And the domain then in that case would be, there's two different ways to write it. Algebraically, you can write it as x is not equal to 3. In set notation, and this is the way you should try and write it in calculus, we say, picture a number line. It's going from negative infinity up to 3. So if we picture a number line, and we're saying x cannot be negative 3, so as an open circle here. So it can be anything in this range, in this area, and it can be anything over here. So it can go from negative infinity all the way up to negative 3, positive 3, sorry, it's my fault, positive 3, and then it skips over positive 3, and it keeps going all the way up to infinity. So in set notation, that's the way you would write it. Alright, can you think of a number that wouldn't belong to the range? The range is a little bit harder, and the question you have to ask yourself, or you have to consider, is, can y be 0? Is there any value of x that would make 1 divided by something be 0? And the answer is no. A number divided by something is not going to be 0, unless that's a 0 up top, and it can't be. So y can't be 0, and why that happens? Well, what would x have to be in order for y to be 0? And as I was saying, there's no number that we can divide 1 by to get 0. So 0 can't belong to the range. Therefore, the range of the function is y can't be 0, or in set notation, it can start down here at negative infinity, go up to 0, skip over 0, and then keep going to infinity. This is the way that we say skip over in set notation. So hopefully that's clear. You should write that down. That's rather important. The most common rules of algebra that limit the domain of the function, there's really only two that we're going to focus on in this class. Rule number 1 is you can't divide by 0. So anytime you have a fraction, you want to look at the bottom, you want to look at the denominator and see what makes it 0. And the second rule is you can't take the square root of a negative number. You get an imaginary number if you do that, and we can't graph those. So since you can't graph it, we can't take the square root of a negative number. It can't belong in our domain. Alright, we've already seen the first example of you can't divide by 0. Now let's think about rule number 2. You can't take a square root of a negative number. If you're given the function y equals the square root of x, What's the domain? Well, if we can't take the square root of a negative number, that means anything underneath that square root sign must be positive. All right, so if y equals 16, if x equals 16, then y be the square root of 16, so you get 4. 16 is in the domain because 16 is the x value. 4 is in the range because 4 is the y value. But what if x is negative 16? Well, if x is negative 16, then taking the square root of a negative, you can't do that. You don't get negative 4. Hopefully you didn't say negative 4. Instead you said not possible. So there's no real number that we can square that will give us a negative number. And I'll say that again. There's no number that we can square, no real number, that we can square that will produce a negative number. So, since no negative number can belong to the domain of y equals the square root of x, the way you write this is two different ways. X must be greater than or equal to 0. That's the algebraic notation. Or you say, and think about it in a number line, we're saying 0. Now x can be 0 because the square root of 0 is simply 0. So 0 is allowed, but nothing down here is allowed. Everything this way is okay. Right? Because 1, I can take the square root of 1, I can take the square root of 2, I can take the square root of 3. I can't take the square root of any negatives. So it starts here and goes this way. So since it can include 0, we put in a bracket, and then it keeps going all the way up to infinity. Okay, what I'd like for you to do, take a minute, find the domain of each of these functions. So what I'd like for you to do is press pause, and on your paper, see if you can write down the answers to these 4 questions. Press pause now. Alright, hopefully you're back and you have unpressed pause and you have your answers in front of you. So for the first one, this is a fraction, so we want to look at the bottom. So looking at the bottom, x cannot be negative 5 because negative 5 produces a 0 on bottom. Okay, the second one, this is a straight line. Slope of 4, x-intercept of negative 17. If you're graphing a straight line, there's no problems. Right? It's all real numbers. For this one, it's a square root. Remember rule number 2. Anything under the square root must be positive. So therefore, for this problem, we're going to say that x plus 9 has to be greater than or equal to 0. So if we solve that, we say x has to be greater than or equal to negative 9. Right, so that's for that one. And then for the fourth one, again, it's not rule number 1 because it's not a fraction. And it's not rule number 2 because it's not a square root. It's just a nice parabola, so it's going to be all real numbers as well. The way you write them, I want you writing them in set notation. So for the first one, x cannot be negative 5. So negative infinity to negative 5. Skip over negative 5, keep going to infinity. For the second one, all real numbers, negative infinity to infinity. For the third one, starts at negative 9, goes up to infinity. X is greater than or equal to negative 9. And then the fourth one, all real numbers. Tonight's homework, you should have it, is the natural domain worksheet. So after seeing the video, you should be able to do the natural domain worksheet, and we're going to talk about this first thing in the morning when I see you in class. So have a good evening, and I will see you then.